YouTube channel. I am Kirti from Sri Venkateshwara College of Engineering. Presently I am pursuing my 4th semester of CSE Data Science. Today I am going to give a presentation on the topic of natural join in relational algebra, which is related to Dbms. So in this topic we are going to cover some contents: definition, common attributes used in natural joins, resulting relation, symbolic representation, examples, comparing the natural joins with other joins, and use cases. Let us get into the topic. Definition of the natural joint. In Dbms, a natural join is like bringing together two tables based on the shared attributes. It's a way to combine data from two relations by matching their common column names. The natural join operation is a relational algebra, creates a new relation by linking the tuples with the same values in the common attributes. It's handy tool for connecting related information from different tables without specifying the column to join on. This is way you can merge the data effortlessly based on the shared characteristics. Common attributes. In natural join, the common attributes are the columns with the same names in both tables that you want to join. These common attributes act as a key to match and combine the data from two tables. By using these common attributes, the natural join operation identifies the matching values and creates a new relation by linking the tuples based on the shared attributes. It's a convenient way to merge the data from different tables seamlessly. Resulting relation. The resulting relation of a natural join consists of tuples that having matching values in the common attributes of both tables. It essentially combines the rows from the two tables based on the shared column names and creates a new relation with the matching tuples. This resulting relation will only include the tuples where the value in the common attributes are the same in both the tables. It's a way to bring together the related information from different tables based on their shared characteristics. Symbolic representation. Here we can see the symbolic representation of the natural join. Here we are having two databases which are R1 and R2. R1 contains the two values A and B, as well as R2 contains B and C. Here when we perform the natural join operation between the R1 and R2, here A, B and C are the natural joins which we can combine together. Here the B will be joined and new relation will be formed. In relational algebra, the symbolic representation of the natural join is the symbol. This symbol is used to denote the natural join operation between the two tables of relation. When you see this symbol in a query or expression, it indicates that the natural join is being performed. It combines the data from two tables based on their common attributes, and it concise way to represent the operation. It is commonly used in database queries. Let us consider one example. Let us say we have two tables which are student and courses. Here student ID is the common attribute among those two tables. When we perform the natural join on the both tables, we will get the result as shown below, like student ID, name, age, course and grade. It will combine both the table and give the output for us. So in previous slide we can see that here student ID is 1, 2, 3 where names are Bob, Charlie and Alice. It contains only student ID, age and name, and the grade which is upgraded in the course table. After performing the natural join, those two tables are joined together and those two are combined to give the new table which consists student ID, name, age as well as course and their grades obtained in the same course. So in this slide we can see both the expression as well as the resulting table in the output. Comparison with other joins. When we compare natural joins with the other joins, we can see some few key differences. So let us consider first natural join versus inner join. Natural join automatically joins the table based on the column with the same name, while inner join requires the specifying join condition explicitly. Inner join returns the rows when there is a match in both the tables based on the certain join condition, whereas natural join matches the rows based on the column with the same name. Secondly, we can consider natural join versus outer join. Outer join includes the rows from the table only matching from the other table, whereas natural join includes all the same attributes with the same column name. Outer joins can be left, right or full, providing the flexibility in including unmatched rows from the one or both tables. Natural join versus cross join. The natural join compares the two tables based on the common column names, whereas cross join produces the Cartesian product or else multiplication of the two joins, and it will present the output as all the possible outcomes from the two joins. After that, we can see the use cases of natural join. Natural join in the database is commonly used in the scenarios where you want to join the table based on the column with same name without explicitly specifying the join conditions. Here are some use cases to natural join that can be beneficially used in database management system. First one is simplifying the queries. Natural join simplifies the queries by automatically matching the table column with the same name and reducing the need to specify the join condition explicitly. This can make queries more concise and easier to write. Second one, data integration. Natural join is useful when integrating data from multiple sources that share common column names. It allows you to combine seamlessly without the need of defining particular join conditions, especially in the situations where schema of the table align naturally. Schema evolution. When we undergo the schema changes or when we perform the table operation and table undergoes the schema changes such as adding, removing columns, the natural join adopts these changes by automatically adjusting the join based on the common column names. This is flexibility can be an advantage of dynamic database environment. Data analysis. The natural join can be benefited in data analysis where we need to combine related data from the different tables without specifying the join conditions. Joining views. The natural join can be used to join the views that are derived from multiple tables. This can help us to create the consolidated views in the combined data based and on the common column names present in the underlying tables. And overall we can say that natural join offers a convenient way to join the table based on the common column names, streamlining the process of combining data from different sources, and it is partially useful in the scenarios whereas tables share the attributes with the same names and simplifies the query writing and data integration tasks. Conclusion. In conclusion, natural join in the database management system provides a convenient way to join the table based on the columns with the same name without explicitly specifying the join conditions. It simplifies the query writing, data integration and schema evolution tasks by automatically matching the table common column names. Natural join is particularly useful in the scenarios where the table share the attributes with identical names, making it easier to combine the data from different sources seamlessly. Understanding the benefits and use cases of natural join can help us to optimize the database queries and streamline the data analysis processes. By saying that, I would love to end up my video. Thank you one and all for watching my video. Please do like, share and subscribe.